in and we'll work through them.
All right.
If you need me to do a problem like the one that we're doing, just let me know, but we'll do this. So it says resolve the vector into components. A vector starting at the point Q equals 4, 6 and ending at the point 1, 2. So it tells you the direction. The first letter is where it starts. The second letter is where it ends. Okay. And to find the vector, you take the X values and you subtract them. Sorry, not there. So you're going to take the second X value 1 and subtract a 4, 1 minus 4. And that's, they use this notation I hat, or in the I direction, the X direction, and then 2 minus 6. And that's in the J hat direction. So the vector is minus 3 I hat, minus 4 J hat.
Oh wait, what's the direction going up called?
The I is like the X direction, and J is like the Y direction, and then K, which we don't have, would be like the Z direction.
Okay. All right.
So do you want me to enter these as we go?
Wait, so the answer is -3 arrow up. How do you enter the arrow?
Yeah, let me enter it, or I don't know. Let me snip that part in, and then I'll show you. So this is how. Let me snip it. So this is how I'm entering the answer, like that. But there's a lot of ways you can present the answer.
Oh, there's no arrow. Okay.
So it's bolded. It's like blacker text.
So the I stands for the X and the J stands for the Y.
Yes.
Okay.
K is for Z.
Okay.
Okay, so I'm going to submit. Hopefully there's no issues with that one. Yay. All right, so now let's go on to problem number 2. Okay, perform the indicated computation. So these numbers on the outside, you multiply them in.
Okay.
Same thing here. So let me grab my calculator so I can get the right numbers. 5 times 0.45. Okay, so we have 2.25 I, and I'm gonna use this little hat because it's faster than writing the arrow.
Okay.
Minus 4.5 J hat minus 0.05 K hat. And then we multiply this in. I'm just gonna use a calculator. I don't want to take any chances here since this is for a grade. So this is minus 0.24 I hat, and then plus 0.002. I think I got extra 0 on the 0.02 K hat. Okay. And so you combine like terms. So like the I hats you combine, and then the K hats you combine. So it looks like 2.01 I hat minus 4.5 J hat or J, and then minus 0.03 K hat.
Okay. Wait, how did you get the second part? The down?
Which one? This one?
No,
or this
the
one?
third one. No, the one in the bottom.
I combined 2.25 and minus 0.24 to get 2.01.
Okay.
And then I just brought this one down, and then minus 0.05 with 0.02.
Okay.
And hopefully these are correct. They are correct. Is that okay?
I might need some more practice to get this.
Okay. Do you want me to give you other problems or keep going through the assignment?
If you continue, is it going to get harder with the assignment or?
This is kind of the same question, so this is a good one for us to do.
Okay.
Okay, so this is what you're trying to do, this part down here, and this is like the given information. Okay, so it's 3 times A, 3 times vector A. So it's literally 3 times 2J plus, and I'm gonna put a 1K. So see where I got A from up here?
Yes.
Plus 7 times B, so 7 times minus 3I plus 5J plus 4K. And then our
Wait,
last one, go ahead,
uh,
from B, there's B.
oh, okay.
And then minus 6 times Z, Z is 1I hat minus 3J hat minus 1K hat.
Wait, how do you put the J hat? How do you enter it in the answer in the computer?
You just bold the bold one. There's a bolded, it's under vectors.
Oh.
I think you can have it open at the same time also, in case you want to look at it.
Okay.
So from here, you distribute the 3 in, so it's 6J plus 3K, distribute the 7, minus 21I plus 35J plus 28K, minus 6I plus 18J plus 6K. And then you just combine like terms. So you combine we should do the I's first. So we'll combine the I's and the I's. So that's minus 27I. And then do the J's. So there's a J, there's a J, there's a J. So that's 41 plus 18, so that's 59J. I don't know why I did that. It's a weird brain thing. And then K. So K, K, and K. So plus 37K.
Okay. Wait, so you combine them? Yeah.
Yeah.
Okay.
And then you have to enter it. So let me enter it. This is good to do just in case I made a mistake during the work through. There's the I plus 59. There's the J. There are other ways to enter this also, by the way. You can also use this angle bracket notation. You might have seen this in the classroom.
Yeah.
So like this is equivalent. And this is how I would write it because it's faster, but
Okay.
the other one's called component form. Okay, so I'm submitting. Hopefully that's right. It's correct. All right.
Wait, how do you have to have the what's it called? The thingy that you just put? The arrow?
Either option. These are called angle brackets, and no, you choose one. I've been entering them the way on the left. Is that okay?
Yes.
Okay. Okay, this question says to find the length of the vector. So there's a formula. So the vectors are in this form. They're A, I hat plus B, J hat plus C, K hat. And the length of the vector, which is given this symbol right here. This is called magnitude. The length of the vector V is the square root of A squared plus B squared plus C squared. So you take the numbers that are in front, 1, -1, and 3. So 1 squared plus -1 squared plus 3 squared, and you square root that. You have those 3 numbers.
With the magnitude, what's this?
That means length. So that's where you're really going to struggle because these words all mean the same thing. Magnitude, length, these double vertical lines, they all mean the same thing.
Okay.
Okay, so that's 1 plus 1 plus 9, so that's the square root of 11. And that's your final answer.
Okay.
Okay, we'll move on to the next question. It is somewhat related. Okay, you are given the vectors below. Find, so see how these double lines? That means magnitude. That means length, magnitude.
Okay. So
So you
A
first,
squared, A squared,
yeah,
B squared.
yep. But this time it's slightly different. You first need to find y minus x. Okay, so here's y. Y is 10i minus 6j minus x. X is minus 5i plus 7j. So all of this is y and all of this is x.
Okay. Y minus X. This is for the.
You got to do this first. You got to do the y minus x first, then you can take the magnitude.
How do you know it's length and magnitude formula?
Because of these double lines.
Okay. Okay.
Okay, so it's 10i minus 6j plus 5i minus 7j. Combine like terms.
Wait,
Fif-
what? Oh, okay.
15i minus 13j. So the magnitude, this time there's just an a and a b. So the magnitude of y minus x is going to be a squared plus b squared square rooted. There is a c squared, but c is 0. There's a 0 k hat here. So you don't have to include that.
Okay.
So it's the square root of 15 squared plus negative 13 squared square rooted.
Okay. Wait,
And
wait,
question?
why did you put parentheses, the B?
Because it's negative, just so that
Oh.
if you do it on your own, it's
There's no C, right? There's no C.
it's 0, so you don't have to deal with it. I don't know if WebAssign will just take square root of 394. It should.
Okay.
Seems to like that. Okay. All right, so next question. Okay, so this question, let me get it framed in here. It says draw the position vector v equals 4i minus 8j. So when you're graphing here, x and y, obviously, you can think of this as I hat and this is j hat. So you go to the right 4,
Wait,
and then
no. Isn't this the X? Oh no, yeah.
it's really I. It's really I. They use I's and vectors, calculus, and physics to some extent, although not a ton, depending on the class you take. So then minus 8 means you're going down 8. 1, 2, 3, 4, 5, 6, 7, 8. But the answer is you have to start at the origin and you draw an arrow out. There's your arrow out.
Okay.
All right, now this one is multiple choice, but let me show you the correct option so that you can see it. It's a better graph than the one that I made. This is the correct answer. You can see they went 4 right, minus 8 down.
Wait, I don't understand.
You're just graphing like I'm trying to show you this is the answer, which is the same as ours. This means 4 right, and this is 8 down.
4 right, 8 down. Okay,
Because it's negative. I mean, if it were positive, it would be 8 up.
that's it. And
That's it.
Okay, okay, okay,
That's
okay.
it. Okay, so next part of the question, it says determine the magnitude of V. Now, V is 4i minus 8j hat. So the magnitude, length,
Wait, how did you get the numbers?
they're given. It's the same as the previous problem. It's part
Okay,
B.
okay,
4i minus 8j.
okay.
Okay, so the magnitude of V is a squared plus b squared square rooted. Your a is 4, your b is minus 8. There is no k, so you can stop there. It says to round to 3 decimal places, so I'm going to grab a calculator. .944. Okay, next question on this one, part C. It says to find the angle between V and the positive X axis. So let me go back to the picture. Let me grab this picture. So they want this angle. Let me do it in red. They want this angle right here.
Okay.
Okay. Now I'm not gonna do it. So there, how do I want to do this? No, I guess we should do that. So there's a formula to find the angle between two vectors. Let me see if that's where they're going with this. Maybe that's in the next one. Okay, so we won't do that. So if you go back to, this is a triangle, 4, 8. If you want this angle right here, I'm going to call this angle theta. The tangent of theta is opposite over adjacent. It's 4 over 8. Okay, so theta is the arctangent of 1/2. 4 over 8 is 1/2. So that's that angle right there. We want this angle in red. So to get that angle, I'll call it beta. Beta is 90 minus theta. So it's 90 minus arctangent of 1/2. Now there's another way to do this problem, but it doesn't look like they've covered it yet in your class. So we will not be using that. But this is just a calculator thing. Give the absolute value of the angle found. Okay, so it's a rounding problem. 90 minus a tangent d 1/2. So it's 63.43 degrees.
Wait, so tan theta equals to 4 over 8?
Yes.
Okay.
Opposite over adjacent. You solve for the angle, but we don't want that angle. We want the angle made with the x-axis. The whole angle is 90 degrees.
90 minus 0? No, how do you do?
Theta, because the whole thing is 90 degrees.
Yes. So the 90 minus, what's it called? TA? Or no?
Tangent. So you find the angle, whatever the angle is. And
just put it in the calculator?
Yes.
So you put just 90 minus tan minus 1. Oh,
Tan inverse, yeah, 1/2 or arctangent.
okay. Okay.
Okay. Next question. Okay, find a vector with length 8, length means magnitude, that points in the same direction as I minus j plus 2k. So a vector that points in the same direction is your vector, the vector that you're given, but you can multiply it by, I'll use C here. if you multiply this by C, it's always in the same direction as long as C is greater than 0. For example, let's just say C is 2. 2i minus 2j plus 4k is in the same direction as this. C equals 3, 3i minus 3j plus 6k. These are all in the same direction.
C,
C is a constant, C is a number.
two.
So in class, they probably did some sort of graphing like this, where there's this X, Y, and Z. So this one I, this I minus J plus 2K, it's right, and then it's going back this way, and then it's going straight up. So it's somewhere here, and it comes out from the origin. It's very hard to see in two-dimensional space, but it looks like that. And so same direction means it's just like this one, but maybe it's longer.
Okay.
Okay, so to actually answer this question, we have to pretend like we've multiplied n by C each time. Okay, so so we got to do it generally. It's C I hat minus C J hat plus 2C K hat. Okay, and then we have to find the magnitude of this. So we have to square this. We have to square the second one and square the third one, square root of that, and that's what equals 8. Feel like I've lost you somewhere here.
Kind of. Yeah, this problem, I didn't really understand it.
Yeah, so this vector, it points off somewhere. But we want the one that's length 8, because the length of this one is 1 squared plus -1 squared plus 2 squared. It's not 8. You know, that's 1 plus 1 plus 4. It's 6. We want the square root of 64. So we have to grow this vector.
Which is 8.
Well, no, the length is 8. So that's where the magnitude comes in. So this is the length on the right, on the left, length, and this is the formula on the right.
Okay.
So you square both sides, 64 equals, this is C squared plus C squared plus 4C squared, 6C squared. You divide both sides by 6. Okay, so your C is the square root of 64 over 6. Okay, and that's what you multiply each of those vectors by. So you have this I minus J plus 2K. So you're multiplying each of these by this thing right here.
Okay.
So this is just take a little longer to enter. Hopefully it accepts the fact that I'm not reducing this. Your instructor may not, depending on, you know, how they feel about reducing. So that's I minus J plus 2. Let's see if it takes this. Hopefully it will. Okay, it did accept that as the
Okay.
answer. Okay, the assignment gets more difficult from here. Do you want us to redo some of the problems or just keep going through them?
We keep go through them.
Keep going?
Yeah.
Okay. All right. Yeah. I mean, there's not that many left. Okay. Okay, find two vectors v in two dimensions so that the magnitude of v is 20 and the I component of v is 12i. Okay. So they're telling you v is 12 and then we need to find this one here. So v, let's just pretend that v is 12i plus k, that's a bad letter to use. Let's use we've been using b times j hat. Okay, and so the magnitude of v is 12 squared plus b squared square rooted. Do you agree with that?
Yes.
But we know in this problem it tells you it's 20. So we're going to solve for b now. So we square both sides. 144 plus b squared equals 400. Subtract 144. And then b is two values. It's either plus or minus 16. So that's why it says smaller value, larger value. So we take that to mean that that is minus 16, positive 16. So we don't know the value here, so we assign it a variable. We write out the formula for magnitude. We know the length, so we can solve for that value.
Yeah.
Okay, so this is a weird question. All right, next question. The figure below is an aerial view of the surface of the ocean. So let's pretend like this is the surface of the ocean. Okay. A ship at point B is on the surface. So there's B. It's right there on the surface. A submarine is 4 units below, and that's at C. Okay, so C is the submarine. It's weird. So this is a distance of 4 below the surface. And a helicopter is 11 units above the surface. So there's A, and that's 11 units above. So it's not really like A and C are not really there. They're actually like up or down from that. Okay. The first set of questions, let me snip these in, asks for, shoot. Okay, so the first one asks for the displacement vector from the submarine to the ship. Okay, so what we really need to do before we even do that, and actually I'm gonna remove this, is we need to write the coordinates for each of these because that'll help to answer these questions. So the coordinates of A is, and see here's X and here's Y. So A is 1 I hat plus 2 J hat, but see how it's above the surface? So that's positive 11 K hat. We're going to do the same for B. B is 3 I hat, 3 to the right, 4 up, 4 J hat, and it's 0 K hat because it's right on the surface. Okay. And then C is 5 I hat, 5 to the right, 1 J hat, And now it's 4 below, so minus 4k hat.
Okay.
And A is the helicopter. B is the boat or the ship. And then C is the submarine. Okay. Okay, now we can actually answer one of the questions they have, because the first question they're going to ask us is find the displacement vector for the following from the submarine to the ship. So that's C to A, or we would write it like this way, CA. So to find vector CA, it's A minus C. Okay, so you take the value in A and you subtract the value in C.
That's for vector? What?
Yes.
Which part?
Yes, we're going to make a vector. We're going to do A minus C. So let me, I mean, you can write it out. It's 1 I hat plus 2 J hat plus 11 K hat. And then you subtract 5 I hat plus 1 J hat minus 4 K hat.
And what happened to the B? Just nothing?
We don't, oh, I'm sorry. I messed this up. Submarine to the ship. Sorry, B to C. Sorry, I just completely screwed this up. Messed this up. Okay. B, sorry, C to B, which is CB. It's B minus C, sorry. So that's 3I plus 4J plus 0K minus 5I plus 1J minus 4K.
Okay.
So you subtract your 5I minus 1J plus 4K. So that's minus 2 I hat plus 3 J hat plus 4 K hat. So let me get that entered. Okay. So the next one is it wants the helicopter to the ship. So let me go back and grab these. That'll help. So helicopter to the ship. So that's A to B. So we're going to do B minus A. So it's B minus A. Okay, so it's 3I minus 1I. That's 2I. 4J minus 2J. That's 2J. 0K minus 11. Okay, so minus 11K. Is it, are you able to follow this?
Kind of.
Kind of, okay. There's really no calculus yet. I mean,
Yeah.
so that's like the one sort of like hope here. So there's no calculus. Part C is from the submarine to the helicopter.
There's no calculus 2 related to calculus 3, no?
No, there is, but you won't see it for a while. So from the submarine to the helicopter, so that's C to A, C to A. So it's A minus C. So this time it's like 1I minus 5I, that's minus 4I. 2J minus 1J plus 1J. 11K minus and minus 4K, so that's 15K, like that. I mean, so far, it's just been adding and subtracting a couple of squared problems. I plus 1J. Okay. So now it wants you to figure out which objects are closest, which two objects are closest together. So what you really have to do is find the distance between all three of them. So it's like going back here and you need to find the distance from A to B, B to C, C to A. And so that's why I guess you did each of these. So C to B, A to C. No, sorry, let me back up here. C to B, A to B, A to C. Okay, great. So we need to find the magnitude of each of these. So we need to find the magnitude of this one. This one right here. So the magnitude of this one, I know this is a little bit, so the submarine to the ship. So the magnitude here, maybe I'll do a different color, is the square root of -2 squared. So that's 4, 3 squared is 9, 4 squared is 16. So that's the square root of 29, it looks like. Okay. And then we're going to do it for this next one. Why am I? So 1. Okay, here's the next one. So this one here, it's got a square root of 4 plus 4 plus 121. So that's pretty far away, square root of 129. So this one's looking the best. And then the last one here you can see is actually going to be worse. 16 plus 1 plus 225. So this is much bigger than this one. So the ones that are closest together is the submarine and the ship. Submarine and the ship. And it's from the distance formula. Submarine and the ship. Okay, I'm going to submit that, and hopefully those are all correct. And then we can move on to the next problem here. All right, so actually there was a mistake in that one. Oh, so actually, I'm sorry. They go, interestingly, they talk about it in 2 dimensions. They say going back and looking at this right here, they're saying which 2 are closest in 2 dimensions, which is A and B, a ship and a submarine. Isn't that what I just selected? We'll have to come back to that. Okay, let's go and look at another question here. Okay, almost done with the first assignment, believe it or not. Okay, so here's a box. It's in 3-dimensional space. There's X, there's Y, and there's Z. And like you're supposed to assume that like the if you remember this from say when you're in high school geometry, you draw a box here. Like these are the same, and then like these right here, they're also the same, but then this one's the same as the one there, and this one is the same as that, and that's the same as that. Like you're supposed to assume all that here. So like for example, A is the same as D, C is the same as F. Now let me enlarge this. Maybe that's part of the problem here. Not that easy to see. So the first question asks about C. Is C equal to F? Here's C and here's F. They look to be exactly the same. Do you agree with that? C is going straight up, F is going straight up. They look the same to me. The next one is, so we'll say true. A and D. So there's A and there's D. They're pointing in opposite directions. So are those the same? They are not the same because they're in opposite directions. One's going that way, one's going the other way.
Okay.
The next one says is A equal to minus B. So what does minus do? Minus flips the orientation. So here's A, minus B is going this way. Well, that's not drawn real well, but it's going the other direction now. So those are not the same. The next one here says G equals F plus A. So let's go find F. F is here, A is there. So if we go straight up and then we go left, is that the same as G? So G is kind of like going up the corner of the box. So it's a little hard to see, but here's the side of the box. G is the same as this right here. That is true. It's like this right here is G.
Okay.
And that does appear to be true. Next one is, it says, and actually let me copy this down here so we can, so much going on in this picture. So the next one is, it says is E equal to A minus B. So here's A, and then minus B flips its direction. So it's like, it would be, so let's look at the top of this. So there's A, that's great. B is going this way, but then it's now going this way. So minus B is going this way, going down. And if you slide B over to this point right here, E is this one right here. So E is going, it's asking, is E going like the diagonal across, and see how it is?
Yes.
Okay. It's okay if you don't. I mean, these are very visual, and not everyone is a visual learner. So it says D is D equal to G minus C. So where's G? So there's G, G's there, minus C. Okay, so it's like you're on the side of this thing. There's G, and then instead of going C up, you go down. So G minus C is this one kind of along here. Is that the same as D? Well, it's going the wrong direction. So D is going right, and G minus C is going that direction. So that one would appear to be false.
Okay.
So the direction matters is the point here. Like they have to be completely in sync with all that.
Okay.
All right, so last question here. This one we will not be able to answer, but I'll just sort of set it up here. This one's probably in Chegg, because there's no numbers, so you may find it's just a perfect match for it. So they give you this figure.
Mm.
They give you this figure, so let me see if I can paste it in there. Yes, they give you this figure, and oops, I guess you can't do that. Sorry. So they say, yeah, here's U and here's V, and they want W. They want W in terms of U and V. All right, and we don't really have time to do this, but the idea would be like you would have to say, okay, how can I get a W out of V? So if I start here, like if I go V, I need to go back that way some amount.
Okay.
So it looks like W might be like V minus U. Okay. And that's how we would figure it out. It might be like half a U, but that's, X is going the other direction, so on. So, all right. So let me actually just pause the sharing, pause this for a moment.